This lesson is on how to report measurements. So what we want to be able to do is to report a measurement such that we give whoever sees that measurement an idea of how good the measuring instrument is. We want to be able to report the measurement with the proper number of decimal places or even just places. Sometimes our measurements won't have any decimal places. So let's start by considering a centimeter ruler. Okay. Oops. All right. So now, when we have our centimeter ruler, it's usually calibrated like this. So we have 0, 1, 2, 3, 4, 5, 6. And you'll see usually a centimeters there. And then we have all these little marks in between, these little calibration marks in between. Okay, so to be able to figure out how to properly report anything that we would measure with this ruler, we're going to blow up the scale. So we're going to look from between 4 and 5 and blow that up bigger. Okay, so we're going to okay. So we're going to bring this here. That's going to be 4. Now, between the 4 and the 5, if you look really closely and count there's 10 spaces. We're just going to make these bigger. 1, 2, 3, 4, 5, 6, 8, 9, and then 10 is at 5. And then we would have same thing between 5 and 6, 10 spaces. So what we want to do is to figure out what each one of these calibration marks represents. So if we're going from 4 to 5 and there's 10 spaces in between, then each one of these represents a tenth. So this would be 4.1, 4.2, 4.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then we have 5.0. So now let's consider that we're measuring something, and what we're measuring comes to there, and we want to report that length. So we can see that our measurement were larger than 4.4, and we're smaller than 4.5. This measurement is in between those. So to get a measurement that's in between these two, we have to go to the next decimal place. So 4.4, and then we're going to estimate. Like if we estimated that we could divide this into 10 sections, we say right in between the 0.4 and 0.5 would be 5. So that maybe is 4.47. This digit right here, we estimated that. Someone else might think that that was 4.46 or 4.48. This digit is called the estimated digit, because different people might have different digits. Now, when we report this measurement, we always have to have the unit. So we would call this 4.47 centimeters. So once we do that, when we figure out a measurement that's in between calibration marks, this sets the number of decimal places for that instrument. So for this ruler, all measurements have 2 decimal places. So once we figure out a measurement that's in between calibration marks, that sets it. So now, suppose we had something that we thought was right on the line at 4.9. we would have to report this as 4.90 centimeters, because we just said all the measurements have to have 2 decimal places for this particular ruler. And that would mean someone else might see that as 4.89, or someone else might think it is 4.91. You might see it as directly on the line, but someone else might perceive it to be a little bit off the line. If you perceived that something was right at the 5, then this would be reported as 5.00 centimeters. So once you figure out a measurement in between calibration marks, every measurement has to have that number of decimal places. So for this measurement, the 0 then is our estimated digit. And for the 5.00, this last 0 is our estimated digit. So for any measuring instrument, you look at where the numbers are, whatever place they are changing. For those calibration marks in between, you go to the next place. So here it's the first decimal place. And then to get the estimated digit in between the calibration marks, you go to the next place. Okay, so let's do another example with a different type of measuring instrument. Okay, so let's get another ruler. And this time, we'll look at, there's a measurement called a spectrophotometer. So we're just going to show a portion of that scale. Okay, so we'll do, so it was 400, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So right here, we're at 500, and then that would continue on. So these are our, okay, and for this instrument, this measures in nanometers. So that's in script and in printing. So nanometers. So now we have to figure out how to report something using this instrument. So again, we see that our numbers are changing 400 to 500 at the hundreds place. To figure out then what our calibration marks are represented, it's 10 spaces to go from 400 to 500. So each space goes up by 10. So that would mean this tick mark represents 410. This is 420, 430, 440, 450, etc., etc. So now we figure out a measurement that's in between tick marks. So let's say we have something that came right there. So we see that anything that comes to this part of the scale, we are greater than 440, and our measurement is less than 450. Our calibration marks are changing at the tens place. So our estimated digit then is at the ones place. From 40 to 50, if this was calibrated, it would go up by ones. So 440, and now I'm going to estimate that. In between, I would say would be at a 5. So I know I'm going to call that a 2. Someone else might think that was 443. Again, this digit, the ones place now, is the estimated digit. So this measuring instrument is different from the ruler that we saw previously. If you put 2 decimal places here, that would be incorrect. Even if you had 1 decimal place, that would be incorrect. You must go to the ones place. So all measurements using this instrument go to the ones place. right? Once you establish a measurement that's in between calibration marks, you've established it for the entire instrument. So if we had, let's see, we'll put that, so this here, we say 442 nanometers is how we would report a measurement there. So if we were, say, here, so this would be 4 to 10, and then from 10 to 20, it looks like it's at the 8. That'd be 418 nanometers. Let's say I thought something was right here. Okay, well, that's 450, 460. This is at 470. So this is 470. To show that this is good to the ones place, I need a decimal point, nanometers. So that might be a little unfamiliar to you, but this decimal place means that this is the estimated digit. Here, the 2 is our estimated digit. Here, the 8 is our estimated digit. So again, this measurement, someone else might have thought that was a little bit before the line and reported it as 469 nanometers. Someone else might have thought it was a little bit over the line and reported it as 471 nanometers. They would all be correct. You can never have an exact amount when we do a measurement. That's different from counting numbers. If I say there are 3 people in the room, then that's exact. There's exactly 3. But when you have a measurement, the last digit, according to your instrument, is always your estimated digit. Even if you have an electronic scale, electronic balance, the readout, the last digit of the readout is your estimated digit. Okay, so again, if we had a something that came and we thought it was right on the 500, it would be 500 decimal point nanometers. So again, we look at where our numbers change, or numbers changed at the hundreds place, 400 to 500. We figure out what the calibration marks are. You go to the next decimal place. Your estimated digit then is at the, not decimal place, the next place, and then your estimated digit is the next place beyond that. So we went from hundreds, calibration was at the tens, our estimated digit is at the ones place for this particular instrument. All right, now sometimes you will have scales that are vertical. In the laboratory, we're often using graduated cylinders. Not the best graduated cylinder to measure volume. So if we have a graduated cylinder, we have to be able to report it correctly. So we might have a graduated cylinder. That's like this, where our numbers are going up by tens, and then we have these calibration marks in between. All right, so to figure out how we report a measurement, we're going to blow up part of this. So we'll blow up here to here. So we're just going to blow this up on our graduated cylinder. All right, so this will be 20, and then we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 30. And our graduated cylinder, this will be in milliliters. Okay, so again, to figure out how to report volumes with this graduated cylinder, we want to figure out if we had a measurement that was in between our calibration marks. So we're going to label these calibration marks. And of course, they're not labeled on the graduated cylinder. You want to be able to fit it in. So going from 20 to 30 evenly, then our calibration marks go up by ones. So this will be 21, 22, 23, 24, 25, right? If our numbers go up at the tens place, our calibration marks go up at the ones place. So now, if we had a volume, and remember that our liquids usually have a curve. So if we have our liquid and we want to figure out what it is, so let's say it's right in between. So we're in between the 24 and the 25. Let's say we're halfway in between, then we will report that as 24.5 milliliters. So this then, the tenths place, the first decimal place, is our estimated digit. So that means all volumes with this particular graduated cylinder that's calibrated like this to 1 decimal place. Okay, so for all 3 of these, the process was the same. You see where the numbers change. The next place after that is where your calibration marks change, and you can fill them in. And then the place after that is your estimated digit. So if we had something that we thought came right at the 30, we would report that volume as 30.0 milliliters. Once you get your measurement in between calibration marks, that sets the places or decimal places for that instrument. Whether they're horizontal or vertical, it doesn't matter. Use the same procedure. And then that way, anyone who sees your measurement understands how good your measuring instrument is. So if we have 40 grams, 40 decimal point grams, 40.0 grams, and 40.00 grams, these measurements are all taken by different instruments. In this instrument, this is our estimated digit. So someone else might thought it was 30 or 20. Here, the ones place is the estimated digit. It's a better balance. Here, the first decimal place is the estimated digit. It's an even better balance. And here, our second decimal place is the estimated digit. It's an even better balance. So when we see a number reported, we can figure out how good the instrument is by the number of places or decimal places. And whenever you're writing your measurement, write the number with the proper number of decimal places and always include your unit. Is it grams? Is it centimeters? Is it nanometers? Is it milliliters? You always need to have a unit when you report a measurement. All right, that's it.